Hey friends, picture this. Right now, at this very moment, there's a colossal dark spot on our sun that's roughly the size of 6.5 Earths. Yeah, you heard that right. 6. And a half Earths. And over the past 5 days, this monster has been throwing the cosmic equivalent of temper tantrums, unleashing over 26 powerful explosions into space, with 5 of them being the most powerful kind we can measure. The biggest one? An X8.1 flare, the strongest solar eruption we've seen in 2026. Now, before your mind goes to disaster movies and apocalyptic scenarios, let me tell you something important. You don't need to panic. You don't need to stock up on canned food. You don't need to build a bunker. What you need is information, understanding, and maybe a really good camera if you live in the northern states, because tonight and tomorrow night, you might witness one of nature's most spectacular shows. The Aurora Borealis, the northern lights, dancing across the sky in ribbons of green, purple, and red. I'm going to take you on a journey through what's actually happening up there on our sun, what it means for us down here on Earth, and why this is both exciting and completely normal. And if you enjoy learning about space weather, solar activity, and the incredible science behind the universe we live in, do me a favor. Hit that subscribe button and turn on notifications so you never miss an update. Trust me, space weather is about to get really interesting over the next year, and you'll want to stay in the loop. So let's rewind to last Friday, February 1st. The weekend was just beginning. People were making plans, grabbing coffee, living their normal lives. And up on the sun, in a region designated AR4366, something incredible was starting to happen. A tiny sunspot, barely noticeable, began to grow. But this wasn't normal growth. This was explosive growth. Within 48 to 72 hours, this small dark patch expanded so rapidly that scientists watching it couldn't believe what they were seeing. It was like watching time-lapse footage of a flower blooming, except this flower was larger than our entire planet. By February 6th, AR4366 had grown to almost half the size of the famous Carrington event sunspot from 1859. And we'll talk about Carrington in just a bit because that story is wild. But here's what you need to understand about sunspots. They're not just dark patches on the sun, they're windows into intense magnetic activity, places where the sun's magnetic field has become so twisted and tangled that it's like a coiled spring ready to release. The magnetic configuration of AR4366 is what scientists call beta gamma delta. I know, sounds like a fraternity house, right? But in solar physics terms, this is the most complex, most unstable, and most energy-packed configuration possible. Imagine taking a rubber band and twisting it over and over and over. Eventually, it snaps. That's essentially what's happening inside AR4366, except instead of rubber, we're talking about magnetic fields with more energy than billions of nuclear bombs. And snap it did. Between February 1st and 2nd, AR4366 unleashed 17 flares. 14 M-class flares and 3 X-class flares. Now, let me give you some context here. Solar flares are classified kind of like hurricanes. We've got A-class, which are the weaklings, then B, C, and M-class, progressively getting stronger. And then we have X-class, the big boys. These are the ones that can cause real impacts on Earth. The most powerful flare from this batch was an X8.1 eruption that peaked on Sunday morning, February 2nd, around 8 a.m. It was the strongest solar eruption in almost 4 months, and the most powerful blast of 2026 so far. To put this in perspective, the Carrington event flare from 1859 had energy estimated at approximately 4 times 10 to the 32nd power ergs. That's roughly equivalent to 10 billion 1 megaton nuclear bombs. Now, our X8.1 wasn't quite that powerful, but it was still incredibly significant. But AR4366 wasn't done. On February 3rd, another X1.5 flare erupted, accompanied by 11 M-class flares. Then, on February 4th, AR4366 fired off another massive XC4.2 flare that caused radio blackouts across Western Africa and Southern Europe. In Australia and New Zealand, shortwave radio communications went dark, ham radio operators lost signals below 30 megahertz for hours, and aviation and maritime communication systems were disrupted. Here's where it gets really interesting. When you have a solar flare, you're getting 2 main things happening. First, there's the electromagnetic radiation, X-rays and extreme ultraviolet light, that reaches Earth in just 8 minutes, traveling at the speed of light. This radiation ionizes our upper atmosphere, which is what causes those radio blackouts. It's like someone turning up the static on a radio channel to maximum. But there's a second component that takes longer to arrive, and it's way more dramatic. It's called a coronal mass ejection, or CME. The X8.1 flare launched a CME that arrived near Earth around 2300 hours UTC on February 5th. Think of a CME as a giant bubble of plasma and magnetic fields being hurled into space from the sun's outer atmosphere. These things are massive. We're talking billions of tons of solar material traveling through space at speeds between 400 and 3,000 kilometers per second. When a CME reaches Earth, it doesn't hit us directly. Thank goodness for that. Instead, it slams into Earth's magnetosphere, which is like an invisible force field created by our planet's magnetic field. And when that happens, it's like someone ringing a bell. The magnetosphere vibrates, compresses, and releases energy, and that energy gets channeled down toward the poles, creating the most beautiful light show you've ever seen, the Aurora. So where do we stand right now on the morning of February 6th, 2026? We're experiencing G1 minor geomagnetic storm levels with KP indices potentially reaching 4 to 5. The KP index is basically a scale from 0 to 9 that measures geomagnetic activity. Think of it like a volume knob. 0 is silent. 9 is a rock concert. Right now, we're at about a 4 or 5, which is like having your music at a comfortable listening level. Tomorrow, February 7th, the activity should drop to KP around 2 to 3, but February 8th might see another G1 storm period. The solar wind, that constant stream of particles flowing from the sun, has decreased to speeds of 300 to 400 kilometers per second, with the interplanetary magnetic field remaining weak at around 6 nanoteslas or below. But here's the exciting part. The BIS component of the interplanetary magnetic field has been weak but south-oriented during most of this period, which favors auroral displays. In simple terms, when the magnetic field points south, it's like opening a door for auroral activity. And that means tonight and tomorrow night could be spectacular for aurora watchers. Active auroras are possible tonight, with northern lights potentially visible from northern U.S. states including Maine, Michigan, Minnesota, Montana, New York, North Dakota, and Washington. The forecast shows active aurora with a chance of isolated minor auroral substorms and favorable conditions for major aurora activity. If you're in Canada, Northern Europe, Scandinavia, Iceland, or Alaska, your chances are even better. And here's a pro tip for all you photographers out there. Bring a sturdy tripod and use manual camera settings. Set your ISO between 800 and 3200, aperture to f/8 or lower, and exposure time between 5 and 20 seconds depending on brightness. Turn off your flash and set focus to infinity, and use a wide-angle lens, 14 to 24 millimeters, works best to capture those sweeping skies. Find a location away from city lights with a clear view to the north. The northern lights are most active between 10 p.m. and 2 a.m. local time, and patience is key. Staying 3 to 4 nights gives you multiple chances, even if one evening is cloudy. Now, let's talk about what's still brewing up there. R1 minor radio blackouts are ongoing, with R1 to R2 minor to moderate blackouts expected through February 7th, and there's a 40% chance of R3 strong or greater levels. As for future flare probability, M-class flare probability remains high at 75 to 80%, and X-class flare probability stands at 25 to 40%, as AR4366 maintains its large, magnetically complex delta configuration. But should you be worried about your technology? Let me give you the honest answer. For most of us, the impacts right now are minimal. Solar flares and coronal mass ejections can affect GPS accuracy because the ionosphere becomes supercharged with particles, and GPS signals cannot penetrate as efficiently. This can cause GPS information to be inaccurate or cause temporary GPS outages, affecting cell phones, cars, and agricultural equipment that rely on satellite signals. High-energy particles can affect satellites, causing misoperation or equipment damage that can put satellites out of operation. Power grids can be affected too. In 1989, a solar storm damaged the Hydro-Quebec power grid, causing a 9-hour blackout in Quebec. When wobbles in Earth's magnetic field induce electrical currents, they may travel through electric transmission lines and into grounded transmission equipment, causing transformer saturation, voltage drops, and overheating. But here's the reassuring part. Power grid operators are now installing neutral blocking devices and other protective measures, and utilities are building capacitor banks and Faraday cages to protect critical equipment. We've learned from history. Speaking of history, let me tell you about the Carrington event because it's one of the wildest stories in space weather history. The biggest geomagnetic storm in recorded history occurred in 1859 when amateur skywatcher Richard Carrington witnessed a massive solar flare, and a day later, Earth experienced the effects of a massive geomagnetic storm. This caused telegraph systems to malfunction, halting communication and creating auroral displays that reached as far south as the tropics. Telegraph operators reported sparks and fires, with some receiving electric shocks. In one recorded case, operators could actually operate their machines using only the current from the Aurora after disconnecting the battery. Imagine that, the Aurora itself providing enough electrical current to send telegraph messages. Today, a geomagnetic storm as big as the Carrington event could cause significant damage to satellites and modern communication technology, potentially causing blackouts across the globe that could take weeks to months to fix. But here's the good news. geomagnetic storms as severe as the Carrington event only occur every 500 or so years. Now, let's zoom out and look at the bigger picture. What we're witnessing with AR4366 is part of something called the solar cycle. Our sun goes through an approximately 11-year cycle of activity, alternating between solar minimum, when things are quiet, and solar maximum, when things get wild. Solar cycle 25 reached its peak in October 2024, with a smooth sunspot number of 161, exceeding initial forecasts. The solar maximum phase is expected to continue through 2025 and 2026 with elevated activity levels. So what we're seeing right now, this is actually completely normal and expected. We're right in the sweet spot of solar maximum. This is also why 2026 is being called the year of the Aurora. We're not just seeing one or two big events. We're likely to see multiple spectacular displays throughout the year, and that's exciting. Now, I know some of you might have heard scary stories about solar storms causing internet apocalypses or wiping out all our technology. Let me address that head on, because there's a lot of misinformation out there. Despite what many headlines have been saying, there's no internet apocalypse on the horizon. These worries began from a 2021 study that suggested a major solar storm could damage undersea internet cables. But experts point out that while solar storms can disrupt GPS signals, radio communications, and power grids, the likelihood of a storm completely wiping out the internet is relatively low. Governments and space agencies worldwide are closely monitoring the sun's behavior to provide advanced warnings when huge solar storms are about to hit us. We have satellites positioned between the sun and Earth specifically to give us early warning. We typically get several days' notice before a major solar storm impacts Earth, which gives power companies, satellite operators, and communication networks time to prepare. So what should you actually do? First, don't panic. Second, if you want to be prepared, here are some practical steps. Keep at least one non-cordless landline phone in your home because it will work even if you lose power. Prepare a family contact sheet with at least one out-of-town contact, and make backup copies of important digital data and information. Fill plastic containers with water and place them in the refrigerator and freezer. Keep your car tank at least half full, and keep medications that require refrigeration in a closed refrigerator. Back up critical data, invest in surge protectors to protect electronic devices from power surges, and ensure you have enough non-perishable food and clean water to last at least 3 days per person. But honestly, the vast majority of geomagnetic scale 5 level storms will not cause catastrophic damage to the electric grid, and on average, Earth is impacted by such storms about 4 times during every 11-year solar cycle. We've been through this before. We'll go through it again, and we'll be fine. Here's what I want you to take away from all of this. Yes, AR4366 is a massive active sunspot. Yes, we're experiencing elevated solar activity. Yes, we might see some minor disruptions to technology. But this is all part of the natural behavior of our star. The sun has been doing this dance for 4.6 billion years, and it's going to keep doing it long after we're gone. What makes this moment special is that we get to witness it with understanding. We have the science to know what's happening. We have the technology to predict it. We have the infrastructure to protect ourselves. And we have the incredible privilege of being able to step outside on a clear night and watch the sky light up with colors that our ancestors could only explain through myth and legend. If you're in one of those northern states or up in Canada or over in Europe, do yourself a favor tonight or tomorrow night. Bundle up warm, and I mean really warm. You're going to be standing outside for a while. Drive away from city lights. Find a spot with a clear view to the north. Bring a thermos of hot chocolate or coffee. Bring a camera if you have one. But most importantly, bring your sense of wonder. Because when you see those ribbons of green and purple dancing across the sky, when you watch them shift and shimmer and pulse with an otherworldly beauty, you're witnessing a direct connection between Earth and the sun. You're seeing solar particles that left the sun a few days ago, traveled 93 million miles through space, and are now painting the sky with light as they interact with our atmosphere. And that, my friends, is absolutely magical. The sun is currently putting on one of its best shows in over a decade. AR4366 might rotate out of view in the coming days, but there will be other active regions. There will be more flares, there will be more auroras, and if you want to stay updated on all of it, if you want to know when the next big solar event is happening, when the best aurora viewing opportunities are coming up, and what all of this means for our technology and our planet, make sure you're subscribed to this channel. Hit that bell icon so you get notified the moment I upload a new update. Share this video with your friends who might be worried about solar storms. Share it with people who love space and science. Share it with anyone who could use some accurate information instead of sensational headlines. Remember, the goal isn't to be scared of the sun. The goal is to understand it, respect it, appreciate it, and when it puts on a light show like the one we might see tonight, to enjoy it. Our sun is an incredible, dynamic, powerful star, and we're lucky enough to orbit it at just the right distance to witness its beauty without being harmed by its fury. So stay curious, stay informed, and if you get a chance to see the aurora tonight, send me a picture. I want to see what you see. Clear skies, everyone, and I'll see you in the next update.